In this video, we'll talk about one-way ANOVA using SPSS. One-way ANOVA is a parametric test that's used to test if there exists a difference between the means of 3 or more groups. So let's take a look at our example. In this example, we have 3 sections coded as 1, 2, and 3. These sections represent Aristotle, which is coded as 1, Plato, coded as 2, and Socrates, coded as 3, and we have 25 scores in each group. So this is how you format your table for if you are to run one-way ANOVA in SPSS. To run one-way ANOVA, you just have to click on Analyze, Compare Means, and One-way ANOVA. So in this window, you just have to move your independent variable, in this case that is the section, to the factor, and move the scores, which is our dependent variable, to the dependent list, and then click on Options and then choose Descriptive. You could actually click on Homogeneity of Variance Test and click on OK and OK. So you see here descriptives about one-way ANOVA, the mean and the standard deviation of the 3 groups, and then you have here the test of homogeneity, the Levin's statistic. If you could recall, one of the requirements for a parametric test, particularly if we are dealing with independent groups, is that they have to pass the test of homogeneity. In this particular case, since we're making use of a parametric test, so we are basing it from the mean, and the sig value is 0.014, which is less than 0.05. This means that we failed the test of homogeneity. However, as they say, we could actually bank or rely on the robustness of the test of analysis of variance and still push through with the test. We just have to take note of that particular limitation that we're able to encounter, such as having to fail the test of homogeneity. Now let's proceed with the ANOVA table. So this is the ANOVA table. Again, you have the between groups, within groups, the sum of the squares, your degrees of freedom, your mean square, and then the f and the sig value. In this case, we just have to get the f and the sig value. We copy this and put it in our table. So that's 10.53 or 10.5, and we have 0, or that's less than 0.01. So once again, if the p-value is less than 0.05, your interpretation will be significant. Again, if the p-value is less than 0.05, the interpretation will be significant, and the decision will be reject the null hypothesis or reject HO. If the p-value is greater than 0.05, your interpretation will be not significant, and your decision will be accept HO. Say, for example, our hypothesis is that there is no significant difference in the scores of the students in the 3 sections. Since we rejected the null hypothesis, our conclusion would be there is a significant difference in the scores of the students in the 3 sections. Since the result of the test yielded significant result, if you'd like to dwell deeper with the result of ANOVA and determine where that significant difference actually lies, you could go back to your data and once again go to one-way analysis of variance. That's under Analyze, Compare Means and One-Way ANOVA, and you may actually choose Post Hoc Test. So Post Hoc Test is basically used to dig deeper with our result and basically identify what particular variables yielded that significant result. So in this case, I'll be choosing Shefei and then click on Continue and OK. ANOVA, by the way, can be considered as a test of multiple t-tests. So instead of doing a comparison between the sections Aristotle and Plato, Aristotle versus Socrates, and Plato versus Socrates, so that's about 3 t-tests, you just run ANOVA. But when you have a significant findings, again, you only do this if you have a significant findings. You may run a post hoc test to see where that difference actually happens. So if we looked at the multiple comparisons here, if we compare Aristotle and Plato, the sig value is greater than 0.05, meaning to say it's not significant. There's no difference. If you compare Aristotle and Socrates, you'll see here the value that's 0.09. Again, that's greater than 0.05. That is not significant. Again, there's no difference. So when you compare Plato and Socrates, you will actually see here that the sig value is less than 0.05. So the significant result is actually influenced by this difference between Plato and Socrates. So if you have if you'd like to have a deeper interpretation of your result, you do not just say that there is a significant difference in the scores of the 3 groups. You could actually add, furthermore, the difference is apparent between sections Plato and Socrates, as revealed by the computed significance value. This is basically t-test now, since you're just comparing 2 groups. So that's basically it for one-way analysis of variance using SPSS.